Hey guys, this is Miss Hart-Townsley, and I just wanted to talk about the 2.02 Early Cells module in reference to the Early Cells lab. And so what I'm going to do, just real quick, this is just a follow-up to make sure that you got out of the lesson what you were supposed to get out of the lesson. So when we're talking about the solutions that we can have cells in, there are three types. So I'm going to call this types of solutions. In your lab, there was a couple misconceptions that I caught really early on with most of you when you submitted your assignments, and that is the dissolving of the membrane, or excuse me, the dissolving of the shell has absolutely nothing to do with the lab itself. All right, so when we're talking about the dissolving eggshell, that's just simply neutralizing that eggshell, and so it just turns into water. We take the vinegar is going to break that down and into a water solution. So dissolving eggshell does not have to do with cellular transport. Okay, and so please, if you are answering those questions or if you got some feedback that discussed that, that's what I mean. The dissolving eggshell just got us to that membrane. Okay, and so now that we have the membrane, we are going to place it in a solution. All right, and so you were asked to place your cell, aka egg, into a 100% water solution. All right, because that's distilled water is 100% water. If you use tap water, you might have a little bit smaller percentage of water molecules, but it's still going to be very high. All right, so you put your cell into this solution, and you have to look at the concentration gradient. So if this is my egg, and I place it into the cell, I need to think about that egg as having a semi-permeable membrane. All right, and so inside this egg, it's mostly water because it's a living organism. So let's just assume that the egg is 85% water. Well, if it's 85% water, then that must mean there's 15% of something else, and we're going to call that the solute. All right, so when I put that egg in the water, the concentration of water, 100% water and 0% solute, is going to cause that water to move into the cell. All right, that process is called osmosis, and we know that that is the passive transport of water molecules across the membrane. Okay, and so the reason your eggs, you were measuring your egg, the reason it swole or got larger was because water was moving in. Okay, on the last question, it asked you to apply your knowledge then. And let's see what would happen to the exact same the exact same cell, which is your egg. So I'm going to make this a little bit bigger. And the egg hasn't changed. We still have 85% water, which leaves us with 15%. I'm just going to abbreviate that S for solute. All right, but now instead of water, we have syrup. Okay, and any of you who have tried to pour syrup or wipe up spilled syrup, you know that it has a very high viscosity, it's very sticky. And so instead of being, or it is a solution though, it's still a solution. And so we could assume that anywhere between 40% water and 60% dissolved sugars, all right, or solute. Okay, and those numbers, those are hypothetical. I haven't looked up exactly what concentration of syrup, but what we do know is that syrup is has a high amount of solute. So even if it's 50-50 or 40 or 60-40, it's going to have a high amount of solute. And so when I put that cell into that solution, my expectation, since this concentration of water is 85 up here, all right, and the concentration of water is 40 down here, water is always going to move from high to low, and therefore I'm going to have osmosis, but I'm going to have water moving out of the cell, all right, because the concentration outside of the cell is lower than the concentration inside of the cell. When I have a net movement of water out of the cell, we're going to call that a hypertonic solution. Okay, so we have a hypertonic solution. So that syrup is a hypertonic solution, and we should see, or we predict, that the egg would actually reduce in size. All right, so if I were to measure that, or if I were to weigh that, I would have less mass or less volume. All right, so, and I forgot to label this one over here. That first one that you tested We refer to this as a hypotonic solution over here because we have water movement into the cell. Hypertonic, water movement out of the cell. We actually have one more type of solution. It's called an isotonic solution. And this is where the net movement of water is equal to 0. So just as much water is moving into the cell as moving out of the cell. And so in our bodies, we try to keep our cells in an isotonic solution. In plants, we like to have hypotonic solutions because that's going to give us that turgor pressure to keep plants really stiff. When you have well-watered plants, they have very firm leaves, crisp leaves, firm stems. When they're underwatered, you can they get softer and they're more bendy and more flexible. And so we really like to have hypotonic for plants and isotonic for animal cells. All right, guys, I hope that clears up a few things. If you have any questions or if you don't understand the feedback, let me know and I'll talk to you later.